Welcome to this Forge College Explainer on synthesizing event-driven design patterns. We are officially wrapping up the Leveraging Events and Logging Mechanisms module in our Solidity from Zero track today. Now, if you were with us for the last lesson, you know we spent a lot of time knee-deep in, well, debugging trauma. Hopefully your night terrors about missing logs have finally subsided, because today we're shifting gears. We are moving from fixing broken things to achieving true architectural mastery. It's all about taking those hard-earned lessons and turning them into a rock-solid foundation for your future smart contracts.
Today's engineering manifest is going to guide us through 6 clear steps. We'll go from debugging to blueprinting, look at events as public APIs, lay down the stable schema rules, apply them to a marketplace blueprint, map out your capstone workflow, and finish up with a quick review and next steps.
All right, let's jump straight into section 1, from debugging to blueprinting and shifting your mindset. It's time to officially step out of that reactive firefighting mode we were stuck in last time.
Okay, let's really dive into this. Stop putting out fires and start drawing blueprints. What does that actually mean for us as Web3 developers? Well, when you're first learning Solidity, it is incredibly tempting to just slap an event into your code anytime you want to see what a variable is doing. It's a totally reactive habit. But today, we're transitioning away from fixing those isolated log errors. We're going to start intentionally drafting events as the robust public instrumentation of your smart contracts. Think about it. You don't draw the blueprint after the house is already built, right? It's meticulously planned beforehand. That's exactly the mindset we're adopting today. Your events are the essential telemetry of your contract.
And that brings us perfectly into section 2, events as public APIs and stable off-chain sync. To successfully architect your capstone, you really have to embrace a total paradigm shift about what an event actually is in Web3. We have to let go of this old mindset where events are just your incidental debug logs. The new reality is much stricter. Events are stable, public APIs. They are absolutely not your personal, messy scratchpad. They are the strict, public endpoints that off-chain archival nodes and UI listeners completely depend on. Imagine if a massive tech company just randomly changed their API endpoint names every Tuesday because a developer was debugging. It would be absolute chaos, right? Well, the exact same logic applies here. If your front-end user interface is listening for a specific event to tell a user their trade went through, and you treat that event like a casual log, you're going to break the entire off-chain application. Moving right along to section 3, the stable schema rules, ensuring ABI stability. Since off-chain consumers treat our events as an API, we have to follow strict engineering specifications to keep everything stable. So here are the 4 core blueprint rules you need to follow. Let's break them down. First up, use explicit versioning. Instead of just naming an event transfer, call it transfer v1. Our blueprint rules mandate that you version events instead of just mutating them on the fly. Second, choose stable primitive types. Stick to primitive ABI types like address or uint256. This avoids tooling breakage down the line. Third, avoid complex nested structs. ABI encoding for deeply nested structs can be incredibly brittle across different indexing tools, so just keep it flat and simple. And fourth, actually, this is a massive one. Always emit only after the final state change. Do the math, update the balances, and then emit the event. Otherwise, off-chain processors are going to be logging ghost transactions, and trust me, nobody wants that. Now, I need you to put on your frugal engineer hat and look at this number, 3. 3 is the absolute hard-coded maximum limit of indexed parameters you are allowed per event in Solidity. So what is an indexed parameter? It's a scarce, costly event field that allows off-chain consumers to efficiently filter and search your logs. Because indexing costs precious gas, you really have to act like a penny pincher here. Spend your index budget only on fields that consumers truly need to filter by, like user addresses or order IDs. If a front end doesn't specifically need to search or filter a certain piece of data, do not index it. Just let it remain standard event data and save your users some money. Let's see how this works in practice with section 4. The Marketplace Blueprint, focusing on practical event design. We're going to stress test these frugal engineering principles on a realistic, decentralized marketplace. Notice in this blueprint how we have 3 main events: order created v1, order filled v1, and order canceled v1. Look at how we strategically index maker and order ID in the order created event. This supports UI filters, but we avoid indexing every single thing to balance searchability with our strict gas budget. A UI needs to filter by the maker to show user their open orders, and an archival indexer needs the order ID to join data. But for order filled and order canceled, we just index the order ID. That is literally all the off-chain system needs to track the life cycle of that specific order.
That right there is calculated blueprinting in action.
And this brings us to the golden rule of backward compatibility: evolution over mutation. Let's say our marketplace eventually needs a new field, like a referral code. We don't mutate the existing parameter order of V1 and break everyone's front ends. No way. We simply append the new field and emit an entirely new order-created V2 to maintain that compatibility. Off-chain processes can easily handle multiple versions just by checking the event signature.
So, how do we put this all together? Section 5, your capstone workflow, 6 steps to mastery. Let's synthesize all these abstract rules into a concrete construction plan for your upcoming Designing Your Hello World contract capstone. If you follow this exact 6-step workflow, you'll turn your contract actions into authoritative, testable payloads. Step 1, identify your critical state transitions. Don't go logging every little helper function. Step 2, define your payloads using compact IDs rather than massive structs. Step 3, choose your max 3 indexes wisely, just like we practiced. Step 4, name and version your events, starting with V1. Step 5, instrument and write unit tests to ensure your events fire exactly when they're supposed to. And finally, Step 6, write your 1 to 2 page instrumentation artifact. This document is a requirement for your capstone project because it acts as the official map for anyone building a front end for your contract.
We've covered some incredibly vital ground today. Let's head into Section 6, final review and next steps. As we roll up our blueprints for the day, let's lock in the core philosophy you need to take into your final project. Never forget this fundamental truth. Events are an append-only audit channel. You are designing an append-only audit channel that serves as a highly scrutinized public endpoint. So choose its shape once and version it consciously. Treat it with the exact architectural respect it deserves. So, what's next? Your next step is to draft a one-page list of actions and state transitions for your Hello World contract. Think deeply about your events, your indexes, and your payloads. But as you draft them, I want you to ask yourself a very serious question. If an auditor or a complex UI had to rely entirely on just your events to rebuild your contract's entire history from scratch, could they do it? That's the gold standard you're aiming for. I highly encourage you to visit forge.college to continue mastering Web3 architecture with us. Explore the rest of this track and dive into tons of other incredible Web3 topics. Thank you so much for joining me on this explainer, brought to you by Forge College. Happy blueprinting, and I will see you in the capstone.